Look up at the night sky. What do you see? A vast, dark canvas. It's sprinkled with tiny points of light. These are stars, distant suns scattered across immense distances. They seem peaceful, don't they? They appear calm, unchanging, and eternal. But this quiet stillness is a grand illusion. The universe is a place of constant change. It is dynamic, violent, and incredibly powerful. Out there, in the silent blackness, events of unimaginable scale are unfolding. These are events so energetic they can outshine entire galaxies. We call these cosmic spectacles supernovae. They are the universe's grandest fireworks display. A supernova is not just a pretty light show, it is far more than that. It represents one of the most significant events in the cosmos. It is the explosive death of a massive star. Imagine a star many times larger than our own sun reaching the end of its life. For millions or even billions of years it has burned brightly. It has been a steadfast beacon in the cosmic ocean, but its time is up. In its final moments, it doesn't just fade away quietly into the night. Instead, it goes out with a bang, a really, really big bang, an explosion so luminous it can be seen across the universe. This single cataclysmic event releases more energy in a few seconds than our sun will produce in its entire 10 billion year lifetime. It is a moment of absolute destruction. The star tears itself apart in a final, brilliant farewell. But here is the secret, the beautiful paradox at the heart of it all. From this cosmic violence, something truly wonderful emerges. What exactly is a supernova? Let's try to get our heads around the sheer scale of it. It's an explosion, yes, but an explosion unlike any other. Think of the most powerful explosion you can imagine on Earth. A volcano, perhaps, or a powerful bomb. Now multiply that energy by 1 billion, then multiply it by 1 billion again. You are still not even close to the power of a supernova. It is a star's final, glorious act. A last desperate roar against the darkness. This is the moment a star dies, and in doing so it seeds the universe with the potential for new life. These events are driven by the life and death of stars. Not just any star, though. To go supernova, a star needs to be massive. At least 8 times more massive than our own sun. Some are even hundreds of times more massive. Throughout their relatively short but brilliant lives, these behemoths burn through their nuclear fuel at a furious rate. They are the rock stars of the galaxy, living fast and dying young. Throughout their lives, these giant stars are in a constant battle with themselves. Gravity, the immense force of their own mass, is always trying to crush them. It pulls everything inwards towards the star's core. But there is another force fighting back. This is the outward pressure created by nuclear fusion happening deep inside the star. This delicate balance between gravity pulling in and fusion pushing out is what keeps a star stable for millions of years. For most of its life, the star is a gigantic nuclear furnace. In its core, it fuses lighter elements into heavier ones. It starts with hydrogen, the simplest element, and fuses it into helium. This process releases a tremendous amount of energy, which pushes outwards and holds gravity at bay. The story of supernova is the story of where everything comes from, not just the stars and the galaxies, but the very ground beneath your feet, the air you breathe, the iron in your blood. Almost every element heavier than hydrogen and helium was created inside a star, and many of those were forged in the final, fiery moments of a supernova explosion. These events are the universe's factories. They are where the fundamental building blocks of our world are manufactured. Without them, the universe would be a very simple and very boring place. It would be made of almost nothing but hydrogen and helium. Think about the elements that make up our planet: carbon, oxygen, silicon, iron. These are the elements of life and geology. They are common here on Earth, but they were not created in the Big Bang. The Big Bang produced only the lightest elements. Everything else had to be made later. Where? Inside the fiery hearts of stars. As a massive star lives its life, it fuses lighter elements into heavier ones. It creates a rich cocktail of elements in its core: carbon, the backbone of all life we know; oxygen, which we need to breathe. These essential ingredients are all cooked up deep inside stars. But creating these elements is only half the story. A star is very good at holding onto its contents. So how do these newly forged elements get out? How do they escape the star and become part of the wider universe? This is where the supernova comes in. When the star explodes, it doesn't just release light and energy. It blasts all those precious newly created elements out into space at incredible speeds. The explosion acts as a giant cosmic delivery service. It scatters the star's enriched guts across vast regions of the galaxy, seeding the interstellar clouds with the raw materials for the next generation. A supernova is a star's final spectacular end. It is a moment of cosmic rebirth, but not every star gets to go out with such a magnificent bang. Our own sun, for instance, will not become a supernova. It is simply not massive enough. It will end its life far more quietly. So what determines a star's fate? It all comes down to mass. The universe has two main recipes for creating these colossal explosions, two distinct paths that a star can take to its own annihilation. Both are incredibly violent. Both seed the cosmos with new elements. But they begin in very different ways, telling two different stories of stellar death. The first path is the most common one we think of. It is reserved for the true giants of the cosmos. These are stars born with at least 8 times the mass of our sun. Some are even hundreds of times more massive. Throughout their relatively short but brilliant lives, these behemoths burn through their nuclear fuel at a furious rate. They are the rock stars of the galaxy, living fast and dying young. Their immense gravity creates incredible pressures and temperatures in their cores. This allows them to forge heavier and heavier elements. But this process has a limit. When their core turns to iron, their fate is sealed. They are destined for a core collapse supernova. The second path is a bit more subtle. It involves not one but 2 stars. It starts with a star much like our sun, a star that has run out of fuel and has shed its outer layers. It leaves behind a dense hot core called a white dwarf. A white dwarf is an incredibly compact object. It is the size of the Earth but contains the mass of the sun. On its own, a white dwarf would simply cool down and fade away over trillions of years. But if it has a close companion star, something dramatic can happen. This is the setup for a different kind of explosion, a type Ia supernova. A star's life is spent creating elements. It fuses lighter atoms into heavier ones, a process that powers it for millions of years. But this stellar fusion has its limits. It stops at iron. So where do all the other heavier elements come from? Where is the cosmic factory for silver, gold, platinum, and uranium? The answer lies not in the life of a star, but in its final, violent death. The supernova explosion itself is the furnace. The extreme conditions created in the heart of the blast are what make the alchemy of collapse possible. It is here, in a fleeting moment of unimaginable energy, that the heaviest elements in the universe are born. When the core of a massive star collapses, it triggers a powerful shockwave. This shockwave rips outwards through the star's onion-like layers. It carries with it an incredible amount of energy and a flood of tiny neutral particles called neutrons. The temperatures and pressures become astronomical, far beyond anything the star experienced during its stable life. The conditions are so extreme that they completely change the rules of nuclear physics. Processes that are impossible inside a living star suddenly become not just possible, but common. The star's dying breath becomes the universe's ultimate act of creation, a final, furious burst of element forging. This is where gold comes from. The gold in a wedding ring, the platinum in a catalytic converter, the uranium that powers a nuclear reactor. Every single atom of these elements on Earth was created in an event like this. It was forged in the heart of a cosmic explosion that happened billions of years ago, long before our sun or our planet even existed. Think about that for a moment. Hold a piece of gold jewelry in your hand. That metal is not of this Earth. The supernova explosion has done its work. In a final, furious act of alchemy, it has forged the entire periodic table of elements. It has taken the simple products of its life and transformed them into a rich, complex cocktail of cosmic ingredients. But creating these elements is only half the story. A star is an expert at holding onto its material, bound by its own immense gravity. For these new elements to have any use, they must escape. They need to be liberated from their dying parent star and cast out into the vastness of space. The explosion itself is the universe's most powerful delivery service, a cosmic cannon firing the building blocks of future worlds across the galaxy. Imagine the scene in the moments after the core collapse. The shockwave is tearing through the star's outer layers at incredible speeds, thousands of kilometers per second. It picks up the onion-like layers of hydrogen, helium, carbon, and oxygen and flings them outwards. Behind it comes the freshly minted material from the explosion itself. The silver, the gold, the uranium, all riding this tidal wave of energy. The star, which was once a neat spherical object, is transformed into an expanding cloud of superheated gas and dust. This cloud, known as a supernova remnant, is a chaotic, beautiful mess of all the elements the star ever created, now freely expanding into the void. This expanding cloud of debris will travel for thousands of years. It spreads out across light years of space, mixing with the sparse gas and dust that already exists between the stars, the interstellar medium. Think of it like a drop of colored ink falling into a vast container of clear water. The ink slowly spreads out, swirling and mixing, enriching the water with its color. The supernova remnant does the same thing, but on a galactic scale. It enriches the primordial hydrogen and helium of the interstellar medium with the heavy elements needed for complex chemistry. The story is not over. The elements are now free, mixed into vast interstellar clouds. But a cloud of gas, however enriched, is not a star or a planet. Something needs to happen to trigger the next step. And, in a beautiful piece of cosmic symmetry, the trigger is often another supernova. When a nearby star explodes, its shockwave can ripple through one of these enriched clouds. This shockwave compresses the gas and dust, creating pockets of higher density. These dense knots can then begin to collapse under their own gravity. The death of one star can therefore directly trigger the birth of a new generation of stars. As these enriched clouds collapse, new stars begin to form at their centers. And because the cloud is rich in heavy elements, it has the ingredients to form not just stars, but also the objects that orbit them. The dust grains, made of silicon, carbon, and iron, begin to stick together. They form pebbles, then rocks, then boulders, and eventually, over millions of years, they grow into planets. This is how a solar system like our own is born. It is formed from the recycled remnants of long-dead stars. The very existence of rocky planets like Mercury, Venus, Earth, and Mars is a direct consequence of ancient supernova explosions. This means that everything on our planet was once inside a star. The iron that forms the Earth's core, which generates the magnetic field that protects us from solar radiation, was forged in a supernova. The silicon in the rocks beneath your feet, the oxygen in the air you are breathing, and the carbon that forms the basis of your body, all of it was created in the heart of a star and flung across space in its dying moments. We are intimately connected to these cosmic events. We are not just living in the universe is living in us. Every atom in our bodies, apart from the hydrogen, has a stellar pedigree. Think about the journey your atoms have taken. Billions of years ago, they were forged in the core of a massive star. That star exploded, scattering them across the galaxy. They drifted through space for eons as part of a giant molecular cloud. Then, perhaps 4.6 billion years ago, that cloud collapsed to form our sun and its planets. Those atoms became part of the primordial Earth. Through geological and biological processes, they eventually came together to form you. You are a walking, talking collection of stardust. You are a living testament to the creative power of supernovae. You are one of the ways the universe has of understanding itself. So we come to the end of our journey, a journey that has taken us from the quiet night sky to the heart of the most violent explosions in the cosmos. We have seen how stars live, how they die, and how in their death, they create the very substance of our world. The story of supernovae is not just a distant, abstract piece of astronomy. It is the story of our own origins. It is the profound and beautiful truth that connects every one of us to the grand drama of the universe. The elements that make up your body, the planet you live on, and the air you breathe were forged in the fiery crucibles of dying stars. It is not poetry. It is physics. You are, quite literally, made of stardust. This simple fact changes how we should see ourselves and our place in the universe. We are not separate from the cosmos, looking in from the outside. We are a fundamental part of it. The laws of physics that govern the life and death of stars are the same laws that govern the chemistry of our bodies. The universe is not just a collection of distant, unrelated objects. It is a single, interconnected system, constantly recycling matter and energy in a great cosmic cycle. The death of a star in one part of the galaxy is directly linked to the possibility of life arising in another. So the next time you feel small or insignificant beneath the vastness of the night sky, remember this. The same fire that forged the stars also forged the atoms within you. You are a temporary collection of ancient stardust, given the remarkable opportunity to be conscious, to think, and to wonder about the very universe that created you. This is not just a scientific fact. It is a source of immense wonder and inspiration. It gives us a sense of belonging to something much larger than ourselves. We are children of the cosmos, born from the explosive death of stars. The quest to understand supernovae is far from over. It is a vibrant and active field of scientific research. Every year, astronomers discover new supernovae in distant galaxies, each one a new laboratory for testing our theories. The universe is full of wonder, and the greatest wonder of all is that we are here to see it. The universe has spent 13.8 billion years creating us. The least we can do is to appreciate what we have become. We are the direct products of that cosmic creativity. The story of supernovae shows us that even from the most violent and destructive events, new beginnings can emerge. It is a story of hope and renewal written across the heavens.